Hello. Okay, any questions?
Sir, can we do buffer overflow attack on Alexa?
Pardon?
Can we do buffer overflow attack on Alexa?
Maybe. Okay, so today we're going to talk about VPCs. Okay, so Amazon VPC, where is it? There we go. So VPC stands for Virtual Private Cloud, right? You can kind of see where is it. Right, so the whole idea is it's essentially your own little network with and you can have subnets and so forth within Amazon's cloud. And you know, part of this is so again, I mean, you know, part of this is we're sort of duplicating or we're sort of replicating this notion, the same sort of notion that we see for on-site networks, right? So what are some of the reasons that that you would use subnetting in a sort of traditional network? Yes, in a traditional network, why would you use subnetting?
So that you can connect more than one device and identify.
Well, I can connect more than one device without subnetting. Why do I need subnetting?
You can have different domains.
Right. I mean, so part of it is, I mean, it's from one standpoint, it has to do with kind of grouping together those things that are logical to group together. So the typical example when you're talking about subnetting are things like, for instance, imagine you're working for a company. Maybe you have something like the payroll system and the employees who work on the payroll system on their own separate subnet. The idea being that we're sort of isolating them and essentially reducing the number of people who have access to those particular resources, right? We could have another subnet for the development people. We could have for the developers. We could have another subnet for DevOps. We could have, right, so various subnets splitting out the sort of responsibilities and so forth, and grouping individuals accordingly. Within the cloud and within kind of the web, right? So one classic example are N-tier applications, right? So we talk about N-tier, meaning, you know, more than one tier. Depending on your application and so forth, that will kind of that will lead you to a particular number of tiers. But to give you an idea, right? So for a web application, obviously, we're going to have a web server, right? The web server most likely is going to need to be able to be publicly accessible, presuming that this is a public website, right, that we want individuals to be able to use. So that has to be accessible publicly. We may actually also have a separate server, an application server, right, the thing that basically is interpreting our server-side language. So typically a web server itself speaks HTML and CSS, right? Then we might have an application server, say something like Tomcat that runs Java stuff, or various other application servers, depending on the particular environment that we're using. The application server, again, that may or may not necessarily be fully publicly available. The idea is the web server certainly is, and it may actually then talk with the application server, but those are separate entities. Similarly, then we can talk about the database, right? Again, so we have a database server. If you're dealing with certain types of compliance issues like PCI, you're actually required to have your database in a separate subnetwork. You're required to actually have firewall rules and all of this kind of stuff to separate these things out, right? And again, the database is a very good example of something that most likely is not going to be accessible directly from the internet. Okay, so that's kind of some of the stuff that we're talking about. That is being able to replicate this idea of subnets and so forth within the cloud. Okay, now one of the questions that obviously comes up is, especially when we're talking about private subnets in the cloud, is how the hell do you access those? Right? I mean, if I'm working for a company and I have a private internal server, right, I can go down to the server room and access the server itself, and we're good to go. Amazon's not going to let me into their server room for good reasons. Okay, so if I have a server, how do I I could probably launch a server into a private network, but then how do I configure it? How do I access it? How do I do all of these kinds of things? Okay, so that's kind of what we're gonna look at, kind of that grander picture of things. They kind of give here's sort of one kind of example image that that they give on their page, and you see a bunch of these types of things. So here we have AWS, we have a particular region and so forth, right? Notice they've sort of boxed off this this VPC, right? The virtual private cloud. They have a CIDR block for it, right? The 10.0.0.0/16 CIDR block. They actually have this split across multiple availability zones, right? And then they have, for instance, one subnet here, an EC2 instance running, right? Notice there are a couple of we have a couple of other components as well. The internet gateway is the thing that is responsible for allowing both traffic in and out of the network, especially when we're talking about sort of public entities. When we're talking about private entities, we'll talk about some other stuff in a bit. Also, there is a sort of routing table for the various networks to detail essentially where packets should be sent and all of that. Okay. Now, depending on your familiarity with networking concepts and all of that, a lot of these terms and so forth are probably familiar to you. The good news is, while there is certainly a bunch of networking jargon, it still is fairly manageable. Okay, so let's take a look at creating a VPC. Oh, actually, I have it here. All right. So, first thing to know is that actually all of your accounts, mine, I've been using Amazon long enough that my account actually is sort of the classic account, which means that I can launch instances without having a VPC. At some point, they made a decision. They said, you know what? They said we're just going to require we're going to force people to use VPCs. We will create default VPCs in all of the regions for the accounts, and so by default, when you launch an instance, it automatically goes into the default VPC. So generally, if you check your different regions and so forth, you'll notice that there are in fact VPCs already created. Right, and again, they're created because those are the default VPCs for the region. Generally, what I like to do, especially if I'm going to start playing around with VPCs, is first go through and label the components as being part of the default VPC. Right. So this one here, it's the only VPC that I have. Right, and so I'll just say it's the default VPC. Okay. I'm going to do the same thing then. You'll notice that they actually have created a handful of subnets for us on that default VPC. And again, I'm going to tag each of these.
This VPC will remain forever. Like if I
Well,
don't even use even a single time.
You can delete it, but then you're going to have issues because you won't be able to actually launch any instances. In which case, basically, you just send an email to their tech support, and they'll recreate your VPC for you. All right. Again, this routing table is
Isn't
part.
this just a waste of IP address?
No, it isn't. Now, we'll talk about sort of how the IP, we'll see how the IP addresses are set up and all that in a minute. Okay, there's the internet gateway. I think everything else should be empty. Yeah, it is. Cool. All right. Security groups. There's a bunch of them there. All right. You can create a VPC via this here. What I actually recommend you do is run the wizard. Okay, so the wizard basically gives you a couple of kind of common configuration options, right? So you notice this first one, VPC with a single public subnet. Okay, so just one subnet sitting in there, and everything within that subnet is public. The one that we're actually going to look at is this one here, VPC with public and private subnets. You'll notice also that there are, for instance, VPC with public and private subnets, hardware VPN access. So you can within Amazon basically you can have a VPN set up so that you can use VPN to connect to your VPC. VPN, remember, being virtual private network. One of the ways to do this is basically you purchase your own hardware VPN access point that you have installed sort of at your own company, etc., that you actually connect to this. You can do it that way. There are also ways of connecting to VPC through a software VPN setup. That is, you can basically create a server within your public subnet that essentially runs one of the various VPN software, and basically then use that to access it as well. Okay. All right. So as I said, we're going to do public and private subnets. Okay. So first things first. Basically, we need to specify the CIDR block for our VPC. So we've kind of been talking about CIDR blocks and all of that. What exactly is a CIDR block? It's a way of specifying which IP addresses you're going to use, right? So if we do. If you're a networking person, typically this is one of these areas that kind of requires a whole lot of thought about things and so forth. But basically, the idea is, let's see, does this one show? Well, let's try that. Right. So here's the basic idea. Okay, the basic idea with CIDR. So before we had CIDR, we had internet classes. Okay, so we had Class A, Class B, etc. And so if you kind of take a look at these, you kind of get a sense, right? So for instance, your router at home a lot of times will use this particular address. Some of them will actually use Class Bs, right? But basically 192.168.0.0, right? The subnet mask basically defines essentially which parts are allowed to vary, right? So in this case, you'll notice that actually the subnet mask 255.255.0.0 essentially says these 2 bytes are the bytes that are allowed to vary. The rest of it basically has to be there, right? So this is this in CIDR would be 192.168.0.0/16. Okay. Now, what's the 16?
16 bits.
It's 16 bits. Right? Basically, so the idea is we're defining how much of the IP address is the host versus the subnet. Right? So, oops. For instance, I could have something like this. right? So notice, here's the net mask here, 255, 255, 255, 0. So the only thing that's allowed to vary basically is that last byte, basically giving me almost 256 possible hosts, right? I say almost because, well, we actually tend to reserve a few, right? So 255 tends to be broadcast, and so on. So we have 0, so we tend to lose a couple. Really, all of this goes back to just a binary representation, right? So 255, 255, 255, 0, right, converted into binary basically looks like this, right? So we have 8 ones, 8 ones, 8 ones, and then 8 zeros, right? And so the whole idea behind masking basically is using bitwise ands to kind of drop through to figure out which things are variable and so forth. Okay, so all we're talking about are sort of bits, and the whole notion is that then we can use the appropriate arithmetic to figure out basically how many hosts we're going to have, we're going to be allowed. So for instance, in this network, right, we since we have 8 bits free, we basically have 2 to the 8 or 256 possible hosts, again minus a couple. Okay, so if we know that essentially we're going to be dealing with 250 hosts, then something like the 24 subnet is just fine. Now with classful, with the IP address classes, they are separated basically on the byte boundaries, right? So you'll see here, right, essentially it takes these 2 full bytes, leaves those alone, and then we have the 2 bytes over here, right? On the other hand, with CIDR, what we're basically saying is, you know what? We don't have to stick to solid byte boundaries. So for instance, I could say let's use 23 bytes to specify that, right? So it kind of takes it takes one additional bit over from the second octet if you're going from the right, basically over here. So that's kind of all the magic that's basically happening. And sort of the more I shorten this, the more hosts that I basically have available to me. Right, so now I have 2 to the 16 number of hosts. I think that's 65,000 or something like that. So yeah, definitely better. So that's all that game is. That's all. It's just a basic numbers game. Okay, so I'm going to go ahead with the defaults here. I will give it a name, so I'll just call it Demo VPC. I'm actually going to use that again, so I'll copy that. Then we can specify our individual subnets. So notice here they actually change. So the individual subnets, basically here it's a 10.0.0.0.24. Same thing here, except notice basically we've just changed that first one to a 1. So we have our public subnet, which is 10.0.0 dot whatever. We have our private subnet that is 10.0.1 whatever. Okay. Again, to make things easier as we're playing around with this stuff later, I'm going to make sure that that all of these have meaningful names. Right. So demo VPC. There's the public one. There's the private one. Right, and you can see it actually will tell you sort of how many IP addresses you're going to get there. So if I look and I go, oh, you know what? Actually, I have a few more, so I could say, okay, let's try 23. Right now, of course, it is going to have some issues there. So maybe we'll do 23. I may actually have to bump this over somewhere there, right, etc. Now, for NATs, we have 2 possible solutions. Notice we have NAT Gateway and NAT Instance. NAT Gateway is basically a highly available service set up by Amazon. Okay, so it's load balanced and all that sort of stuff. It does fairly good in terms of bursty traffic. It actually allows bursts up to 10 gigabits per second. So fairly nice. The downside is that since this is kind of a service used by numerous people, essentially you don't have as much room for configuring it. So for instance, if I wanted to set up port forwarding, I can't do that with a NAT gateway. The other thing that I can't do with a NAT gateway, and the reason that I'm not going to use a NAT gateway today, is because with a NAT gateway, I don't have the ability to use that as a Bastion host. How many people have heard of a Bastion host? Okay. So a Bastion host is the answer to how do you access things that are in a private subnet from outside the network. What you basically have is a machine in the public subnet that acts as your point of contact to allow you to then connect on to those other machines. So in the case of Linuxes, most of the time basically your Bastion host will allow you to SSH into the Bastion host and then SSH to the private subnet. In the case of Windows, you'd essentially have a Windows server that is running RDP that again you could basically then use to connect to your private Windows instances inside. Okay, so if you want to sort of use the NAT together with Bastion functionality, basically you want NAT instances. Okay.
It's basically like proxy. So like
Yeah, it is essentially it is a form of a proxy essentially. You're right. Okay. Again, the NAT side of things, whether it's a NAT gateway or whether it's a NAT instance, okay? The main purpose of those is simply to allow your private, your stuff in private subnets to be able to connect out to the internet, to connect out to the internet. Okay, that's the whole point behind either a NAT gateway or a NAT instance. We're going to use the fact that we can also sort of enslave the NAT instance as a Bastion host to allow us to actually get in as well. Okay, the other way essentially would be using some form of a VPN. All right, yeah.
So from the point of view of architecture, there will be like one NAT and two subnets, and the NAT will connect all three sides. Yes.
So basically, right. So basically, what you have, you have your overall VPC. Your VPC basically, in this case, is broken down into two different subnets. I have a public subnet and I have a private subnet. In the public subnet, I will have my NAT instance that that also will be used as a Bastion host, and that will allow me to then connect into any of the instances in the private subnet. Is that what you're asking? Make sense? Okay. All right. So yes, there's this. Let me go ahead and grab a key. Yep, there's that one. Okay. I don't need to actually do anything else with any of this other stuff. So I'm actually just going to leave that. Yeah, again, we'll make sure that's all good.
instance type, is it same as that we were doing for?
Yes, because literally what it's doing is it's spinning up an instance that is running Amazon Linux that basically has NAT software installed. So I actually have a link someplace here. Yeah, this one here. That I believe this one actually talks about if you were configuring it yourself manually, if you were setting it up manually, then you can actually look at. Let me see. They tell you, yeah, right here. So this is the string that you would search for in the community AMIs to find the AMIs for a NAT instance, right? So that's all it's doing. It's just sort of spinning up an instance with one of those AMIs that basically runs the NAT software.
What if I want to use a different rather than using an Amazon?
You can, you can, but you're likely gonna have to configure all that stuff yourself. All right, so notice it did in fact launch and so forth. Let's take a look at what we have and all of that. So since I launched a NAT instance, notice now I actually do have a running instance in EC2, right? If I come over here to take a look. So yes, there's the Ruby demos that I did from last class. Actually, my previous class to coming here. Right here's here's the instance. Let me go ahead and tag this. Right, so this is NAT /Bastion. Okay, so now I know. Now, when you set it up from the from the wizard, what it will automatically do for you is it will allocate an elastic IP and assign that to the NAT instance. Okay, the elastic IPs within Amazon basically allow you to get a static IP address for a particular service. Okay, the pricing on it is weird. Where you mainly accrue charges is if you have an elastic IP allocated that is not associated with a running instance. Think about it. Basically what they don't want everybody doing is say, give me a static IP and then not have it hooked up to some service that's actually running. Right? So when you do that, you actually get charged a fee, a small fee, and so there you do want to be careful. And again, I'll show you kind of how to shut everything down so that you aren't going to accrue those charges. Right, so there's my NAT instance. I should be actually, let's see. Am I able to log in? No, I'm not able to log in just yet. Right, so in fact, let's try that. Do the search. Really? Okay.
So the elastic IP is an IP of a public network or a private network?
Yeah, notice. So notice. There's the IP address that I have. There's the elastic IP address, 34.238.183.100, right? So this is actually a public, this is an IP address for public consumption. Versus my VPC, notice where I'm using basically the 10.0.0, which are those that are reserved for private use. Okay, so my general IP addresses for those subnets are going to come in here, but I also have a public IP address for my NAT instance.
So what about the router? What
Pardon?
IP address is router?
Sorry?
What is the IP address of the router that is connecting into the internet gateway, the network?
The NAT essentially acts sort of like a router, right? Now the router itself, we'll see how to configure in a minute, because you actually don't get its IP address per se, because really, honestly, none of this exists. This is a software-defined network. Right? So it's not like there's actually a physical router there, et cetera, but I have routing tables and so forth for configuring it. Okay. All right. Anyways, let's go to PuTTY. Okay, so Amazon EC2, and let me just grab this. And I'll just save that for right now. Right, and it's not going to connect. Okay, by default, the security group that it's given doesn't have the permission set to allow us to SSH into that. Okay, but again, that's simple enough to do. Right, so I'm going to select it here. Then then I can scroll down to the security group. Click on that. Right, so here's the rules for our security group. Right, again. Tag that as such. Okay, so inbound, basically what I'm going to say is, okay, so I'll edit this. I will add a rule specifically for SSH, and I can just do maybe something like this to allow that. Could have also put in USF's CIDR block itself. All right, so now I have SSH access for the internet gateway. Let's go ahead and try. I'm sorry, the NAT instance. Let's try connecting into to that.
Sir?
Yes.
What was the purpose of not including SSH in the security group? Like, the machine is
well, the issue is not everyone's going to use their NAT instance as a Bastion host. You don't have to use it as a Bastion host. just happen to be using that because I want to show that. I want to show
So
how to do that.
How will you use the network that you created if you can't even interact with it? Like,
How do you, again, wait, how do I use which?
like I've created a network, but
Right.
I cannot interact with it because there is no security group there, like SSH or RDP. Then how am I supposed to like interact with it? And
So again, your options for your options for interacting with your VPC are either you have a Bastion host, and again, I mean that Bastion host. So there's nothing actually preventing me from, for instance, using the NAT gateway and then standing up my own Bastion host. Right, so I could do that. I could use the NAT gateway side, then have a separate Bastion host based on, again, whether I'm dealing with Linux, whether I'm dealing with Windows. So that's one way. Another way is I would set up some form of VPN, whether I'm dealing with their hardware VPN, whether I'm dealing with software VPN, etc. Set up that to allow me to access. Right, so it kind of depends on your use case and all those kinds of things. Right, so but the NAT instance, I mean, by default, the NAT instance job is to allow things that are in the private subnet to get access out. Okay, so by default, its security group doesn't have SSH into it turned on, right? But we can, as you can see, we can actually just SSH in. Other questions, issues,
So next steps, we will create instances in public and private.
Yes. Right. So now I do have an instance in the public subnet. Right. How do I know that? Let's take a look. So if I go back over to the dashboard here. So here's my Bastion host. Right. Let's see. So one, I could certainly look at the IP address here, right? And so I can see that's in the 10.0.0 subnet. I know that is my public subnet. Let's see. Does it list the subnet here? Instance. Yes. There. So it gives me the subnet ID, which then I could actually come back over to here. Notice I go to subnets here. Right now we have all of these things. Right, so here, let me just do, there. Now I can filter that out. Right, so notice we have the demo VPC public, right, and its ID is 99B. Oh, yeah, actually, here's the subnet ID. Yeah. So the subnet ID is 4C6. Okay, so we can see, yes, this is actually installed, is launched in that particular subnet. Okay. Let's look at launching another instance. So what I'm going to do is I'm actually going to launch an Ubuntu server into the private subnet. Couple of things. One is so again, I want to show how we can use the Bastion host for actually connecting to private things, and I'm deliberately selecting Ubuntu here rather than Amazon Linux, so that it'll actually be really clear when we do the login, kind of which machines we're logged into, whether it's the Bastion host versus the Ubuntu server, and you'll see what I mean in a minute.
Can we use in private network Windows machines?
Yeah. Absolutely, right? I mean, I can use Windows machines, I can launch those. Then basically what I would want is I would need to create a Bastion host, a Windows Bastion host that basically has RDP set up that's running on it to allow me to connect in RDP so that I could RDP into the private subnet.
So we can do it like in this NAT we created. We cannot create.
Right, you can't do it off of the Amazon NAT instance. All right, so yes, there's my Ubuntu server. All right, we'll go ahead and grab that. Right, yes, we'll use so there's the usual stuff. So I'm going to go ahead and allow it to select the channel. Why is that? Usually, isn't it? Anyways, all right, that's totally. Launch instance. Playing with this all day yesterday, for whatever reason. Okay, fine. On this screen, or if your review and launch was working, whereas mine wasn't, what you'll ultimately need to do is come to the instance details. So here is where you decide basically what subnet you're going to use, what VPC you're going to use, as well as what subnet, right? So notice I have these. It has the various options. It actually is giving me demo VPC as the selected one. But there is also the default one. Then we need to specify whether we want the private or public subnet that we're launching this into, right? So that's how you do that. Okay. Auto-assign public IP address, right? So again, the question is, do we need a public IP address for this particular instance? If it's in the private subnet, no, right? And generally the best way of doing this is leaving this on use subnet settings, right? So if it is a private subnet, then basically it will not issue a public IP address for that particular machine. Okay. Let's see, anything else here? Yeah, there's all that. Let me go ahead. So let's add in the usual. I'll do the basic Ubuntu one. Grab everything except for upgrade, and then we'll go over to here, paste that in. All right, so there's that stuff. The security group, I'll just check it out. Notice, so it is allowing SSH from anywhere, so to speak. Now, if I'm especially paranoid, I could actually change this to the IP address of my Bastion host to say, okay, the only way you can get into this is directly through the Bastion host, right? In that case, though, right? So the IP address that I would actually use is the private IP address of the Bastion host, not necessarily the public one. Since this is already private, I'm not going to bother breaking this down further. Okay. All right, so review and launch. All right, so that's that. Again, double check the instance details. Yes, it's going into the subnet. Okay, let's launch this. Grab our key. All right, right. So again, notice our NAT or Bastion, right? It does have a public IP address. If you needed to find out the private IP address, right there it is. So that would be the address that I would ultimately use for specifying the security group rule. Again, if I was hyper paranoid. Okay. Now, notice our private Ubuntu server. Right? Again, notice there's no public DNS. That's good. That's what we want. If it's in the private subnet, it really shouldn't have a public DNS. It also should not have a public IP address. Okay. We do have a private IP address. Notice it's on the 10.0.1 subnet. So that's good. We know that it's in our private subnet. Now the question is, how do we actually connect and so forth? Okay. So let's take a look at this.
So by default, we can access network from the private. Our user data, for example, can use a web request and it will be routed.
Yes and no. There's some additional configurations that we're going to have to do. We'll see. All right. PuTTY. So let me load up again our connection to the Bastion host. Right. And again, don't really care about that. Okay. So SSH Ubuntu at. Do I have a PuTTY window sitting there? Yep, timed out one from before. All right. This one you do have to select yes. If you type no, it won't let you log in. Right. So notice does permission denied public key. Okay. So basically, It's not letting me log in. Now, can I ping it? Let's see. Not even getting a response back ping-wise. Okay, but this issue about dealing with the public key. Basically, the way that we solve this is to use SSH agents. Okay, so in my EC2, my Amazon EC2 thing, I can come down to SSH here, and if I go to auth, notice there's this option for allow agent forwarding. Okay, so I'm going to turn that on. Now I'm in. Right? So by turning on agent forwarding, basically, since I already have loaded up the Dropbox key, and that's what I've actually used to log into to the Bastion host, basically that information is forwarded on to the Ubuntu server as we try to log in. And so now we can see that yes, in fact, we are right. It's Ubuntu. There's the IP address, etc. Now let's see if we can access the interwebs. Nope. Okay. So we can't do that because we need to actually fix some of the additional rules. Okay, so let's take a look at that. All right. Under route tables, you'll notice we actually, so there were in fact two created for us, right? You'll see that one sort of dubbed the main, one has a subnet associated with it, etc. Right? So this one here that has a subnet associated with it, if we take a look at it, right? First of all, if I go to subnet associations, I can see, oh yeah, this is the route table for the public subnet. Okay, and the routes themselves are actually fairly straightforward, right? So, okay, anything on that particular network that stays local. Other stuff, this stuff here, basically anything else goes to IGW. IGW stands for Internet Gateway. Okay, so the Internet Gateway that kind of gets automatically also created with our stuff. That's going to handle that. The one that doesn't have a subnet associated with it is the one that I'm now going to modify. So what I'm going to do is, first of all, I'm just going to come to subnet associations here, and I'll click edit, and then I'll just select the private network, the private subnet. Right? So select that. Now this routing table is going to be associated with that particular subnet. Then I need to edit these rules. And for these rules, essentially what I want to do is take this this default rule and say, let's actually send that over at our NAT, right? So I don't want that traffic going to the Internet Gateway. Instead, the NAT is actually what's supposed to be handling that. So I just, again, just delete out what happened to be there, select the NAT host, and click Save. All right. Yes, we still have that. Let's try pinging. Right? Still nothing. Right? Why? Again, security group. We go back over to here. There's our NAT. We go to its rules. And essentially what we want to do is we want to edit this rule right here. Okay, so they put in this default rule. I have no idea what this is. I haven't been able to track down exactly what it's setting there. But I do know that I don't actually want that. Instead, basically what I want to say is that we'll accept any inbound traffic from our private subnet. So that's the 10.0.1.0.24 subnet. Okay, so anything on the in the private subnet is allowed to connect to to the the NAT instance. All right, so having done that, okay, notice we're still alive. And our instance has the ability to phone out, right? So now I can do things like apt get update, right? It will actually get those, etc. Yeah.
So can you briefly again explain routing table and the roles? What do you?
Yeah. So the routing table. Let's go back to here. Okay. So rules like this are kind of a default rule. Basically says, okay, anything else, right? So here, notice we're saying basically anything within the subnet within the subnet for our VPC, right? So the 10.0.0/6 that defines the entire VPC, right? So it says, okay, that basically allows anything within the VPC to talk to one another. Okay. Then we say that in this case, right, what we're going to do is we're going to allow for we're going to route other traffic out to which one is this? This is the right. This is actually routing it out to the NAT instance. Right, so anything that is non-local traffic, we're going to try to send to the NAT instance to have it basically send out. Okay, and then similarly, you have a set of rules for the public subnet as well, right? So in the public subnet, again, anything that's part of the VPC itself, yeah, that's just local. Other stuff we're going to send out to the internet gateway.
So internet gateway is kind of another computer.
It is, right. It's basically right here. Okay. So the job of the internet gateway is to provide sort of that bidirectional public access for those things in the public side of stuff, right?
Can we configure firewall rules like here on the internet gateway?
Yeah, so you can you have a whole host. While I can't define it directly on the gateway, okay. So there's a number of ways you can control traffic. Okay, one is by specifying the routes, right? So as we see, I could say, okay, routes for this type of traffic send through this particular thing. We have security groups like we had previously. We have them, but we do have them on the instances. We also have them sort of attached to the subnet or to the network itself, right? So we have our network security group, so to speak, for that. Additionally, you have NACLs. Okay, so you have yet another layer for doing some additional configure, and basically NACLs versus security groups gets down to stateful versus stateless types of firewalling, right? So NACLs are more stateful, the security groups are more stateless, and so again you can use all of them together to kind of custom shape depending on your risk tolerance and all of those. All right. Questions, issues, etc.
How would I connect to either the SSH forwarding key?
Yes, I'll find the link. There's because that'll show how to do it for the Mac. Yeah, there's basically the SSH command is just an option or something that you set. Let me show you one other kind of cool thing. So notice that logging into our private server is kind of this two-step process. We log into the Bastion host, and then we're logging in, and then we SSH to the private network. I can actually set it up. So let's do this. Let me I'll load up this first, and then I'm going to call this. Okay, so for this, again, we'll make sure that agent forwarding is turned on. The other thing, though, that I can do is under this option here. So under the SSH option, notice there's the remote command. So I can put in SSH Ubuntu at grab the IP address of my private server and paste that in. Okay, so let me go ahead and save this. Right. So now, I'm logged directly into the Ubuntu server, right? So basically, it connects to the Bastion host. It automatically runs the remote command that I gave it, which is to SSH to the private server, and so this is all we get.
If you do exit, it will come back to Amazon, or it will exit from the whole thing.
Sorry?
If you do an exit command, it will come back
Right.
to-
So if I exit, actually notice it just kills the entire thing, right? So it shuts down my entire part. All right. Other questions, issues, etc. There it is.
So the Ubuntu is my private network and the Amazon is my public network, right?
Say that again?
Amazon is the public network and the Ubuntu machine is the private.
The Amazon Linux NAT instance is in the public subnet, and the Ubuntu instance is in the private subnet, right?
Which if I have to install Apache, I have to install on both the machines separately, correct?
Well, it depends on where you want what services you want. So, for instance, if I want a public web server, then I need to install it on a public server. Now, I probably wouldn't put it on my NAT instance. What I would do is actually I would spin up another instance in the public subnet and install Apache and whatever else that we need on there to be able to be accessible. Right, so that's generally what you want. On the other hand, if I was building something sort of like an intranet or something like that, or possibly a database, there I would probably actually put it in the private subnet, and then basically use these kinds of techniques to access that. Okay. Other questions?
I have
issues?
2 users in my private network. Okay.
Pardon?
I have 2 users in my private network.
Okay.
So how can I do that? Like this is just the one. If I'm supposed to.
No, these are regular, right, so the number of users doesn't matter because these are regular Linux servers, right? So if I have another user on the system, I could have multiple users running all connected to the system, and that's fine.
And suppose someone do their DOS attack on the public IP address.
Right. So in that case, by default, it doesn't actually handle that. Now there are some write-ups for basically different ways that you can kind of get around DDoS attacks within Amazon using Amazon services and all that. So yeah. All right. Other questions, issues, etc.
So from a penetration testing point of view, is it possible to access my private network without the key?
So the issues, right? So from a penetration standpoint, right? And so whether we're dealing, right? So whether we're dealing, for instance, in a VPC or a sort of traditional network, you still have the same kinds of issues, right? Companies routinely will have a network where, for instance, they have an intranet that is a separate network that's basically sort of walled off in a sense from that it doesn't have direct access to the public internet, and so in that case, right, it's really the same type of issue. So the issue is, one, can I, in this case, right? So in this case, we only have 2 servers. I have the NAT instance and I have the private server. The only thing that's accessible publicly is the NAT instance. So that's my only target. I have to, from a penetration standpoint, I have to find some sort of vulnerability and exploit for this public server. If I can do that and get in, then I can sort of start branching out from here to access other stuff, right? Because the NAT instance obviously does have access to the private subnets and so forth, right? That's always the game. And whether it's cloud, whether it's your own sort of homegrown network, it's still the same. Yeah.
Also, question. So it's not yet Bastion because we do not allow traffic inside to the private, no? it's not Bastion host, it's just NAT that allows traffic from private.
No, it is a Bastion host, right? So the Bastion host, right? Because the NAT instance. So remember, the idea behind a Bastion host, it's in the private side. I'm sorry, it's in the public side. It's in the public subnet, and basically allows you to then gain access into the private side of things, right? So that's the purpose of the Bastion host, basically allowing you to go from the outside to get in, right? The NAT instance, which also happens to be our Bastion host, does the opposite, which is it allows those things that are sitting inside the private network to have access out to the internet, right? Basically works really the same way your router right? I mean, a NAT instance really is kind of the equivalent of your home router, right? That's how you can have 60 devices all running at home, even though your internet service provider is providing you likely with a single IP address, right? So your router typically has NAT software installed that basically does that for you. All right. Okay. All right, so let me exit this. Okay, so let me show you how to tear this stuff down and not incur hella charges. This actually bit me. I had a point where I was getting a $40 bill a month from Amazon, and I couldn't figure out why. And it had to do with I left some of the VPC component. In particular, the Elastic IP address was sitting there. So yeah. All right, the private server, right? So before you can delete your VPC, you have to get rid of the instances that are running in that VPC. Okay, so I have the two instances here. So let me go ahead. I'm just going to go and select terminate. Okay, so that's for the private one. For the Bastion, right, I'll select terminate, but notice there's this little option here, almost hidden, that if I spin this open, okay, it gives me the option for releasing the Elastic IP address. Now, if you forget, it's fine, right? In fact, I'll show you what happens. So, right, so if I didn't put this in, because actually most of the day yesterday when I was playing around with this, I kept forgetting to spin this open and do this. So anyways, but the way that you do it basically, so again, so the preferred way, just spin this open and select it. If you didn't, let me show you how to get around that. Okay, so it's shutting down, it's terminating both of those. Now I should be able to go to, wait, is it this one? I think it's in this one. There we are. Back under VPCs, I can go to my Elastic IPs, right? Notice I only have one. So this is the one that my NAT instance was using. Okay, so I can dissociate the address, which basically says, right? So right now that IP address is associated with my NAT instance. That's this idea of dissociating, right? So here, the IP address isn't associated with an instance at all. In other words, I'm incurring charges now. Okay? Actions, release address, bye-bye. Okay, so now the IP address, the Elastic IP address, I have given that up. My servers are pretty much shut down. Yes, there we go. They're both terminated. So now I can come over to my VPCs, right? So here's the demo VPC. I can just go ahead and delete that. It spins a little bit, but then it will delete the entire VPC. It will actually delete the subnets, the routing tables, all of those kinds of things.
So first I have to delete the EC2 instance?
Right. First you have to terminate your instances before you need to terminate your instances before you can delete the VPC. If the instances aren't terminated, when you go to delete the VPC, it'll basically say, I can't do it because there's instances running. All right. And so notice, if I go to subnets, right, again, I still have my filter here for demo VPC. I don't have any of those subnets. If I take out the filter, I do have my default ones in there. Again, routing table, notice I still only have, I have that one. Internet gateways, I only have the internet gateway for the default one, right? We've already seen Elastic IPs, NAT gateways, we didn't have one anyways, etc. All right. Questions, issues, etc. So that's kind of how you set it up, how you can manage, and all of that. All right, so to that end, you have an assignment to basically kind of work through all of this stuff, etc. So if you take a look, you're for the most part duplicating what I've done. There's a couple of little hiccups here that I'll just kind of mention briefly. So, I mean, mainly, I am having you play around with these CIDR blocks. So notice I've given you the CIDR block for the VPC itself. You do have to play around with the CIDR blocks for the public and the private subnet, right? So notice I've specified, okay, public subnet starting at 80, and it has to have space for 59 hosts. Another a private subnet on this network with space for 507 hosts. So you can play around with the numbers and all of that to figure that out. In terms of submissions for this, you're going to do a few things. So one is to properly grade this, the TAs are going to actually have to access your running system. Okay, so that means you're basically going to set up your VPC and you're going to leave that running together with those two servers. Okay. The TAs are going to need to log into your Bastion host and to your Ubuntu instance. Okay, to do that, basically what you're going to need to do is you're going to need to take a key file, an SSH key file, and deploy it to both your Bastion host and to your Ubuntu instance. Okay, essentially, I give you the public version of the key. Myself and the TAs. The TAs don't know this, but they have it, or they will have it. Have access to the private key. And then we'll be able to use that to log in. Right now, how do you do that? It's actually not that hard, right? I have this little write-up here. Okay. This is the public key itself. Okay. Basically, what you're going to do is once you've got your Bastion host set up, you're going to SSH into the Bastion host. You're going to type this cat greater than to .ssh/authorized keys. When you do that, it will just sit there like it's waiting for something, because it's waiting actually for input. At that point, what you're going to do is you're just going to grab all this, copy it, and then paste that into the terminal. Hit enter. It'll still be waiting for input. You then hit Control D. Hold down Control, hit D. That stops the input. You do that on your Bastion host, then you do the exact same thing on the private server. Now, myself and more likely the TAs will be able to log into to both of those using our private key. Okay, so like I said, you're going to leave the VPC running. You're going to leave the instances running. Once it's graded, then they'll send you an email saying, okay, you can take the stuff down, and you can take your stuff down. The other stuff that you're going to submit, you're going to actually take a bunch of. So here's essentially for that, right? So you're going to submit in the text box for the assignment. You'll submit the elastic IP address for your Bastion host. Also the private IP address of your Ubuntu instance. In terms of attachments, there's a bunch of screenshots that you're going to take, and so I have some examples just to give you an idea of kind of what you need to show in your screenshots. So you'll actually take those various screenshots, you'll zip those up. That will be an attachment to this assignment as well. Questions, issues, etc.
In case we need to know that the SSH key has been done, that we have set it up and they can access it, can we ask the TAs to check it once?
I suppose you could. I mean, follow the instructions, it should be fine. But yeah.
Just considering it does not run when
I actually thought about writing a quick little Lambda and API gateway thing to allow you to just submit this information and have it check. If I get the time, maybe I'll do that. All right, that's it for today. See you next time.